everyone, this is a video tutorial on valence shell electron pair repulsion theory, or usually just abbreviated Vsepr theory. We're going to use Vsepr theory to predict the shape that a molecule will take on in three-dimensional space. Its basic premise is this: all of the electrons that are contained within the molecule will push one another as far apart as possible to minimize any repulsion that they may feel. This basic premise is going to dictate all of the shapes that we'll see when we're trying to predict them for various molecules. Let's take a look at a couple examples. Okay, so for example, let's say that you have one central atom that's attached to two other atoms. You have a few ways you could consider orientating them. One example is to think of them orientated in this fashion. Now, this particular shape would not work for Vsepr theory because these two atoms here are 90 degrees apart from each other, and there is a better way to place them so that they're even further apart. So what you could do is you could put them like this, where it's a linear shape now, and these two are 180 degrees apart. That's the maximum they can be apart from one another, so this is the most minimal repulsion that they could possibly feel. Let's take a look at another example. Okay, so let's take a look at another example. So now I want you guys to picture a central atom with four other atoms attached to it. And using Vsepr theory, I'd like you to think about a way that you could maximize the distance between your atoms and minimize the repulsion. Now, for most people, the shape that comes to mind is this one right here, where you have a 90-degree angle separating all of those bonds. Now, if our molecules were existing in two-dimensional space, then this would be completely correct. But the issue is that we sometimes forget to think three-dimensionally, and our molecules do exist in three-dimensional space. And there is a much superior shape that increases the angle far beyond 90 degrees. That shape is going to look something like this. So this here is called tetrahedral, and the angle that we achieve in a tetrahedral shape is 109.5. So now we've maximized the distance between them in an overall three-dimensional orientation. This is the gist of what's going on in Vsepr theory. Take your central atom and all the atoms that are surrounding it and all of the electrons around it, and picture in what orientation three-dimensionally can I expand the distance between these electrons so that the repulsion between them drops dramatically.